Okay, so we are going to go through section 1-3 today. That's all we're going to do. The good thing about this course is that it's not so dense, like say a college algebra or a 0314 intermediate algebra, that we have to just be hammering material every day. There will be some days that we cover a couple sections, but we should be able to steadily go through. It should feel like it's a medium, medium easy, medium hard, depending on your background. It should be a medium overall average difficulty class. Okay, like I said, when we're talking about the course outline, is the real chapter to be on your game on is 8. That is the one that is hard for almost everybody. So, but other than that, I think we're off to a good start. Let's see if we can knock this out. Some of you guys are going to probably breeze through this homework and pass me by, and that's great. And then I haven't loaded the quiz yet, but it'll be there. Okay, with that said, if a student saves $24 per week, how long will it take to save enough money to buy a computer? What necessary piece of information is missing that prevents solving the problem? So we're not actually solving the problem from a numbers and cents standpoint. We're solving the problem when it comes to what's missing to solve this actual problem. What's missing there? What do we need to know to do it?
The first one.
Yeah, the price of the computer, right? So we can't really know what to save for if we don't know how much it costs. So the computer price is what we are missing. Okay, next. If it takes you 4 minutes to read a page in a book, how many words can you read in 2 minutes? What are we missing there? Numbers of words on a page. There you go. Oh. Well, it's probably good for you to be on that video. Go for it. Go on.
Okay.
This is Mrs. Cox. She's from the Academic Support Center. You're going to be on video. I'm recording this also from my home class. So it's good for them to see them.
Good. Well, like I said, my name is Donna Cox. I am from the Academic Support Center. The reason I'm here, this is contemporary. Make sure I'm in the right place. I want all of you to be aware of some resources that are available to you. And that is, in the Academic Support Center, we have math tutors available at all hours that we're open. Yeah, I see an eyes. Yes. Every hour that we're open, we've got tutors in there, okay? Does everybody know where the Academic Support Center is? I know I see some familiar faces. Okay.
No.
For those of you that don't know, the easiest way to explain it is if you would go over here where there's an elevator, take it and go to the first floor and head that direction and keep going out the door and then follow the path around. You'll come to picnic tables. When you get there, look to your right hand side and you'll see a sign that says Academic Support Center. You go right. And if you look up here on the board, those are our hours of operation. We're open every day except Saturday. And our phone number is right there. So I would suggest that you write that down. So if you have any questions about anything that I tell you, you have a number that you can get a hold of us. Okay? So like I said, any hours that we're open, we have tutors available. Now, along with that, we have, for those of you that bring your own laptops, we have Wi-Fi connections so you can come in and get your homework done using your own laptop and then get help, or you can get on our computers. Those of you that don't carry your laptop around, okay? We have some workshops going on throughout the semester on things like test-taking skills and test anxiety. If you have a question about any of those, give us a call or come by and see us. And one important thing that I want to mention to everybody is, has everybody gone on to their Canvas classroom? It looks like everybody's doing it now. Yes? Have you seen the little place that says tutor.com on there? Yes? I saw one head bob. Does everyone know what I'm talking about? If you'll look, when you go onto your page, there is an area that says that has some things listed on the left of it, and it says tutor.com. That is an online tutoring service. Okay? You can access that 24/7. That means if you're like I was, and after midnight, you can go onto that site and you can get help. okay? You already have minutes, put them. If you find that you're using a lot and you need some more minutes, that's when you want to use the phone number and call us and ask. Say, hey, I'm using it, can I get some more minutes? Okay? Does anybody have any questions? Okay, thank you for your time.
Thank you, appreciate it.
Enjoy your week. I'll go this way.
Okay, all right. All right, on to problem number 3. A salesperson receives a weekly salary of $450. In addition, $15 is paid for every item sold in excess of 200 items. How much extra is received from the sale of 213 items? So instead of, say, missing information, in this problem, we have some information or a piece of information that's not necessary. If you're looking at yours, work yours for sure, but if you're following along with me, you should be able to determine what is missing, or I mean, what is extra, sorry. What is extra in my problem? Weekly salary. We don't need that information, right, to answer the problem, okay? And so now, how much extra is received? Now we start to get into the actual, let's go solve the problem. And so we'll start to see the problems that come after this. We actually need to go and calculate that. So let's go take a look at this. So we don't care about the weekly salary. That seems to be a piece of information that is irrelevant to our problem. We should be able to answer this problem with the other information given. So let's okay, there we go, a little better. Okay, so $15 is paid for every item sold in excess of 200 items. How much extra is received from the sale of 213 items? So all we need to do, of course, is determine how many extra items we've sold. Of course, in this problem, that means we've sold 13 extra items, right? So 13 extra items at $15 per item, and that's just simply multiplication, right? So 13 times 15, what is that? Somebody got it? 195. And so that's extra on top of the weekly salary. Now, we don't need to add those two together, right? We don't need to add the base salary with the essentially commission, right, or extra, because all they ask for is how much extra is received. Any questions about that at all? Hopefully you guys are doing your problem concurrently with mine. Let's keep on going. All right, so in the next problem, it says a parking garage charges $3.25 for the first hour and 25 cents for each additional hour. If a customer gave the parking attendant $45 for parking from 10 a.m. to 3 p.m., how much did the garage charge? So, again, just like the previous one, there's a piece of information in there that we don't need. What is that piece of information? Correct, you got it. Why is that? Because they didn't ask for the change, right? If they asked for the change, then that piece of information would be relevant. But because that is not asked, we don't need to really know how much the person gave the attendant. Okay? So there's that one. How much did the garage charge? So again, we got a little problem to do, and so let's go figure that out. So in order to figure out how much the garage charged, we have to figure out their, I guess, billing structure, if you want to call it that, and then figure out how much time we spent in the garage, and then calculate the amount that we need to pay. So for example, or in this example, the garage charges $3.25 for the first hour. So hour 1 is at $3.25. And of course, you don't have to do the problem the way I'm doing it. Do it whatever way you want. If you can do it all in your head, that's great. Do it all on your calculator, that's great too. Just get it done and move along. Then 25 cents for each additional hour, plus X number of hours at 25 cents per hour. So we don't know how many hours it necessarily is yet. This is just their fee structure. So if, again, parking attendant, irrelevant, 10 a.m. to 3 p.m. So 10 a.m. to 3 p.m. puts us at what? 1 hour from 10 to 11, right? So we're going to have 1 hour at 3:25. In other words, 1 hour times 325, or essentially 325, right? We didn't really need to do actual math on that, but I just wrote it out. But then how many additional hours after, say, 11 o'clock? Because remember, the first hour is at a higher rate, a much higher rate, but each additional hour after that is at a lower rate. So, but you don't want to calculate 5 hours here because the first hour you already ran, right? So 10 to 11, we're at 325. Then 11 to 12, 12 to 1, 1 to 2, 2 to 3. We have 4 hours at the lower rate of 25 cents per hour. And so, of course, that's an easy multiplication. That's $1, right? And so the answer is $4.25. So first hour at $3.25, each additional hour at 25 cents. We spent 4 additional hours in the parking garage, and so 4 times 25 is $1 extra. Add those two together, your answer is $4.25, which is what you should be paying the garage. And so here it is. Any questions about that at all? Okay. Now go work yours. Make sure you can get yours correct. On your problem, you might have a different base rate, a different additional hourly rate. You might have a different amount of time spent. You might have a different start and end time. So it's going to depend on your problem, but as you can see, the principles are still the same. Okay? Any questions about that at all? Anybody not getting it on theirs? Okay? All right, let's keep on going. Then I'll take a little bit of a break to come around and just see how you guys are doing. All right, let's move along to the next one. One person earns $41,000 per year. Another person earns $2,100 per month. So let's pause for a moment here and let's write this down. So let's say person A makes $41,000 per year. Now, it's important that you notate that in this problem because you can clearly see that they're not comparing apples to apples. They're comparing apples to oranges because the other salary is given per month. Okay, so important that you recognize that in this problem, and FYI, at problem number 5, you should find that they're no longer asking you what piece of extra info or what's missing. They're not asking you for that anymore. We really kind of transition and just do the problems. So anyway, so with that said, pay attention to that first or those first 2 sentences that in your problem, you might have different numbers, but the bottom line is that they're comparing apples to oranges. We have different units that the salary is given in, years, months. How much more does the first person, person A, earn in a year than the second? How are we going to compare these two? Well, we have to compare these two. If we're comparing how much more does the first person earn in a year, keyword year, right? So that means that everything has to be apples to apples, year to years, which means that B needs to be converted to years, a salary in years. Now, if they said, how much more does the first person earn in a month than the second, then we would convert this year salary to months. But because we're comparing year to year, we need to multiply this one by 12, right? Because that's going to tell us how much this person makes in a year. What's that going to be? 24, 25, 2? Did somebody do that for me? 25,200. Good, excellent. Thank you. So this person makes, after the conversion to years, $25,200 per year. We're not done. You don't want to put 25.2 in there, right? What you want to do is you have to really answer the question, which is how much more A earns than B. How do we figure that out? Simply subtract the two, right? We have to find the difference. Subtract the two. Find the difference between the two. And what's that going to be? 48, 58, 15.8? 15. Was that for yours?
No, wait, am I right?
Maybe your, it can't be 50 for mine because this ends in a double zero.
Yeah.
Is it 15? What is it, 15?
I wrote, yeah.
That's okay.
15,800.
All right, good. There we go. Awesome. Thank you, everybody, for contributing. That's nice. So 15.8. Thank you. And so there you go. I mean, I won't always type the answer in, but you guys get the idea. Okay? So hopefully you guys are getting through your problem. And that's really the more important thing. I'm here to do as many problems as possible, but really ultimately we want to make sure that you understand what you're doing and you're able to successfully get through your work. Okay? And so I would rather you get through your work. And if you can follow mine, great. If you need to follow mine, definitely follow it. But most important, get through your work. Okay? All right, let's move along. After problem 6, I'll take a quick break. So it says a television sells for $750. Instead of paying the total amount at the time of the purchase, the same television can be bought by paying $100 down and $50 a month for 14 months. So what we have in this problem is we have essentially a, what's the best way? A now price for this TV, pay for everything right now, up front, right? And then we have what? A finance price or a payment plan, right? So this is essentially a finance TV and the other option. So if you buy the TV now, you're going to pay $750. If you finance it, you're probably going to pay more. That's typically what ends up happening, unless it's 0%, and we'll get to all that later on when we get to chapter 8. So if it's financed, you don't have to put as much down right now to have the TV now. You just make payments, but in the end, you're going to pay a little bit more for that. That's how typically it works. So let's figure out how much we pay more. Well, first and foremost, before we can figure out how much we paid more by financing, we have to figure out how much we paid by financing, right? So paid $100 down. That means that on the day, you pay $100 plus $50 per month for 14 months. What does that mean? So that means you're paying $50 a month for 4 months. That's why I multiply it by 4. So I have my $100 that I put down on the day, and then from there, I know that I'm paying $50 per month for 14 months, not 4, 14. And then the total of that is going to be what I paid for that TV. Okay? What is that? That's going to be 500, 200, 700?
700.
Thank you. And then $100 plus 700 is 800. So that's how much I paid for the TV. I probably shouldn't box it. That's not necessarily the answer, right? In fact, it's not the answer. What do I need to do with that 800? X, what amount is saved by paying the total amount at the time of purchase? Well, to figure that out,
Subtracted by
you do
the
what?
750.
Yeah, exactly. We subtract the two. So the difference between these two is the answer. $50 is saved by not paying for the TV in payments, not making payments on it. Now, if that's significant to you, good. If it's not significant to you, and you can do something better with the money by not paying for it right now, then that's fine too. But know that by financing it, you pay a little bit more. And sometimes by financing it, you pay a lot more. It just depends on the scenario. Okay? So I'm going to take a little bit of a break there and come around and make sure you guys are on the right track. And a quick note, if for some reason you happen to get a question wrong, you can always do similar exercise to get it right, if you didn't know that already. So there will be some instances where you're working on your homework and you can't get to 75% because for whatever reason you've got a bunch of problems wrong. You can go back and do similar exercise and get that problem right to get to your 75%. Okay? All right, so just FYI. Good, nice job. Good. All right, I'm going to take it since I've got some people that are like at problem 11, that we're on the right track, and let's move forward to problem number 7. All right, so let's take a look at this one. This one happens to screw students up all the time. Some students get it, some students struggle with it. My goal is to help you understand this scenario. So it says calculators were purchased at $65 per dozen. Let's stop right there, okay? So let's stop there and let's make sure we understand what that's saying. $65 for how many? What do you get for $65?
You get 12 calculators.
You get 12 calculators, okay? So that's important to know, okay? So stop right there to understand first that a dozen means 12 if you didn't know that already, and $65 gets you a dozen. All right, sold at $20 for 3 calculators. Stop right there. So you're selling them at $20, so you buy at this, you sell at this, $20 for 3 calculators. So essentially what are you doing? You're buying them maybe wholesale, repackaging, and selling them for a little bit more so that your total ends up being more, or the amount that you generate in revenue ends up being more than your expenses, right? Now, what is the profit on 6 dozen calculators? This is what really throws students. So let's now understand, what is 6 dozen? 6 dozen means that we've got 6 times 12, right? Or 72 calculators. So what we want to know is, what's the profit on 72 calculators? Well, in order to figure out the profit on 72 calculators, there are several things you have to do. Ready? Here we go. Step number 1. What is your cost for 72 calculators? Let's go figure that out first, right? What is the cost? What does it cost us to purchase 72 calculators before we even go and repackage them and sell them? So if it costs us $65 for a dozen, or 12, then how much does it cost us for 6 dozen? Well, it costs us what? 65 times 6. By taking 65 times 6, we find out exactly how much it costs us as the retailer to purchase our product that we're going to repackage and sell at a margin of some sort. What is that? That's what?
$3.90.
$3.90. Thank you, guys. Okay, so there's $3.90. I'm going to put a circle around it because it's an important number, but it's not our answer. Okay. So then, step 2 is to figure out our revenue. Now, revenue oftentimes is confused with how much you make. Making is not revenue. necessarily. Revenue is what you take in before expenses, before you subtract out how much it costs you. Like for example, I mean, we often see, like when we go to a business that is doing really, really well, and we go, oh my gosh, they probably make millions of dollars. Well, sometimes a business might not be doing so well because their cost could be like, if they take in $1 million, but their expenses are $950,000, they're not making very much money. So that's where I say the word margin. It depends, right? So, and then of course there are businesses that have huge revenues, very minimal costs. That's a profitable business. The margins are good. So anyways, they're starting to introduce you to that concept. Okay, so let's figure out our revenue on 72 calculators. Well, how do we figure out the revenue on, and I kind of helped you here, it was a little bit of a hint that you needed to figure out how many 6 dozen was, right? Because if I know that 6 dozen is 72 calculators, how do I figure out how many packages I can make from 72 calculators? Divide by 3. Exactly, great job. So if I take the 72 calculators I just purchased and I divide it by 3. Why do I divide by 3? Because in this particular problem, my business, I'm selling them in batches of 3. Yours might be batches of 4, batches of 2, batches of 5. I don't know, it might change for you. So know that that 3 is not fixed, right? It depends on what you are repackaging them into. Also, is that 72 fixed? No, because your problem might have been 5 dozen calculators, 8 dozen calculators, whatever it was. You got to figure out for yourself how many individual calculators you purchased so that you can then figure out how many smaller packages you can make of them. Does that make sense? Okay. Pay attention to that. So of course, that leaves me with what, 24 packs of 3, right? And that's for my problem. Yours could be different. You could have 20 packs of 4, 15 packs of 5, whatever it happens to end up being. Why do I need to know how many packs of 3 I have? Because that's what the $20 is. Does that make sense? So I have to take the 20 now and multiply it by the 24 to know how much revenue I'm generating off of those 72 calculators. So I don't take 72 and multiply by 20 because I'm not selling them individually. I'm selling them in groups of 3. I can make 24 groups of 3 that I sell for $20 per group of 3. Somebody got that number? 480? 480? 24 times 20? 480. Okay, thank you. And so, what is that? $480 is the revenue I generate off of the sale of 72 calculators because they are repackaged in groups of 3. You guys following me? Neither of these are the answer, are they? Because step 3 is to actually figure out our profit. Profit is your revenue minus your cost. So if I want to know my profit, I figure out what did I sell my stuff for, what did it cost me to produce or purchase. That tells me what my profit is. That's what I've made. You don't make 480, right? You got to figure out how much it cost you first before you can even jump to the conclusion of how much you made. So of course, that one is obvious. We've been doing it for the last couple of problems. And so my profit margin is $90. That's what it's known as, a margin, right? Profit margin. The margin on the sale of 72 calculators is $90. You guys understand now? Okay. So if you ever end up running your own business, you end up getting into accounting, basic finances stuff, this is important to understand. It's a really basic topic that you should know. You should know that every business has a profit margin that factors in their revenue and expenses. If your revenue exceeds your expenses, you're profitable. If your revenue is, or if your expenses exceed your revenue, then you are not profitable. You're losing money. If your revenue equals your expenses, you're breaking even. And so what you hear is that whole statistic of when you start your own business, typically the first 2 to 3 years, you don't make any money. So not making any money is the equivalent to not profiting. You have no margin. In fact, what they say is your first 2 to 3 years of business, you probably lose money. So, or at least the first year they say you lose money. So I hope that makes sense. I hope that gives you a little bit of understanding about how basic profit, revenue, and cost works together. Okay, so there you go. I'm going to skip number 8 and let you guys do that on your own time. Let's go to number 9. Okay, so on number 9 it says the car rents for $240 per week plus 50 cents per mile. Find the rental cost for a 2-week trip of 500 miles for a group of 3 people. There's actually a piece of information we don't need. What is that? The people, right? It doesn't say that you're gonna pay per week, per mile, per person, right? It says you're just paying for the base, right? The base weekly rate, and then the rate per mile. So your trip is a factor of your base rental fee plus the dollar per miles driven. That's what your rent or your rental is going to be based off. So you have a base fee of $240 per week, and then you have an additional fee of 50 cents per mile. So let's go take a look at this. So I'm going to just kind of note that our base is $240 per week, and our cost per mile is 50 cents. Okay, so then once they give us the information, we can kind of plug that in there and see what happens. Find the rental cost for a 2-week trip. Stop there. 2-week trip. Immediately, that should indicate to you that they have just given us the base part of it. So we need to take 240 and multiply it by 2. I think most of you guys would have already gotten that. That's not that big of a deal. I think you can figure that out. So, but I'm just putting it in kind of an equation form. You don't have to do that. So 240 times 2 will tell me the base cost or base rental fee for those 2 weeks. Then 500 miles tells me how many miles I drove. So what is that? 50 cents per mile times 500 miles. So those two things combined are going to tell me my total rental fee. What's 240 times 2? Should be, that one's easier, 480. 50 cents times 500, that should be 250. And so what is that? 530, 730? Maybe. Something like that. And then note that it's round to the nearest dollar in the event that you have a 50 cent extra while you bump it up. Okay? So there it is. There's your rental problem for number 9. I hope it makes sense. A lot of you guys, just seeing this first half of the room or first third of the room, you guys are already way ahead of me. So I bet a lot of you guys are almost done at this point. So that's good. Okay. If you're moving alongside with me, that's great. So as long as your goal here is to be with me. If you're ahead of me, that's great. Okay. And of course, when I say, if I skip a problem, I say, hey, go do that on your own time, try to literally just put that off to the side and join with me on the next one. Because usually if I skip a problem, it means I think that based on what we've done before, you'd be able to do it on your own. Okay? So what you don't want to do is get caught up in that problem because you're so motivated to get that done, that you end up not learning the one that I covered, and then now you're behind. It happens all the time. So, anyways, this one is important. If you haven't done this one yet, let's go take a look at it. And it's not hard once you see it, but for some reason, students get messed up on this one too. All right, let's take a look. Jasmine decided to ride her bike from her home to visit her friend Justin. Okay, so let's draw a little picture here. Jasmine is going to go to Justin's. Okay, so she's going to ride her bike. 4 miles from home, her bike got a flat tire. So I'm going to just kind of start the problem and tell you that this problem is, maybe I should go a little further with the scale. This problem is about figuring out how much she biked, she walked, and so on. So that's why I'm already starting to kind of go through it this way. 4 miles from home, her bike got a flat tire. What does that mean? That means she biked for 4 miles so far. You guys following me? Yours might be different. She had to walk the remaining 2 miles. So she walked the rest of the way to Justin's. You guys following me? That's what's happening so far. So as of this point right now, I'm here. She could not repair the tire over at Justin's and had to walk all the way back home. Well, do we have enough information for the distance back home?
Yeah.
Yeah, clearly. So she had to walk 6 miles back, right? How do I know that? Obviously because I added 42. Now, how many more miles did Jasmine walk than she rode? Okay, so this is a comparison, right? We've done a lot of comparisons all class long. How many more miles did she walk than she rode? Well, she walked what? 6 plus 2, which is 8 miles. Important piece of info, but not the answer. She biked 4. Important piece of info, but not the answer.
It is the answer.
Well, that is the answer. Good job. In a different context. But good job. I like that. That was good. It is the answer. So it is 4. Okay. Any questions about that at all? Okay, makes sense? Awesome. All right. 11 is an important problem. We're going to do that. And so I'll give you just a moment to do whatever you need. And then I'm just going to check this video, make sure it's still rolling. Okay, perfect. All right. Depreciation, important concept. This is another, just like that revenue, cost, profit problem. That one problem is huge in terms of from just a life skill, understanding that, or at least having been exposed to it. This one is another. I think we all understand that when you purchase a vehicle, there are almost no vehicles that appreciate in value. Everything depreciates, meaning that it loses value. So this problem is about depreciation and calculating how much a vehicle loses value over time. And most things depreciate. Some things appreciate, like typically real estate, homes, those typically appreciate. And other things might, but cars, the majority of cars will lose their value. So that's why you never want to, if you can help it, when you're young, dump your money into a nice car, big set of rims. Those things are dumb. They really are just not good things to put your money into when you're younger. How do I know? Because I did it, and it was dumb. So, in fact, I was just talking with my mentor a few days ago, and he's been looking to buy a computer, and I go, hey, here's one for $800. He goes, nope, can't do it, gotta buy tires for my car. And he doesn't have an expensive car or anything, just a basic SUV. And I go, and because his tires were going to cost $800, and we started laughing because I have an older BMW, it's like a 2012. And at the time, it was a nice car when I bought it back in 2013. And I was like, oh man, I want to put these nice rims on it. And so I bought these M5 wheels for my 5 Series, and those rims were $3,000, okay? $3,000 rims, absolutely stupid. The tires on them were even more stupid, because every tire to fit those rims was $400 a tire. And so thankfully when I bought the rims from a guy, they came with the tires for $3,000, but those tires only last like 30,000 miles because they're racing tires. And so, just bad. And so anyways, when it came time to replace the tires, like 20,000 miles later, because the tires had 10,000 when I bought them, cost me, I got a discount on them, it cost me $1,200. And the next set of tires only lasted like 28,000 miles before I had to change them. Needless to say, I put those rims back on the BMW for him and sold them to a guy. And now what am I driving? I'm on my old 18-inch rims that came with the car, but even then, though the tires to replace on 18s are expensive. My tires, I just changed them $500. Now those will last 65,000 miles, but it's ridiculous. On another note related to depreciation is my BMW, and this is again, stupid purchase, would never buy another BMW again. I paid $50,000 for that BMW back in 2013. Thought it was a baller, it was stupid. You know how much Honda wanted to give me for that car back in November when I wanted to trade in for a Civic?
How much?
$11,000. $11,000 for a $50,000 car. And you want to know something? I bought that car used with 10,000 miles on it. A year earlier, that car's retail price was 65 grand. That's crazy. Do not do that. Okay, don't do that. In retrospect, you know what's crazy is you think about it, right? If I had just kept my basic Acura that I had from 2000, if I'd taken the money that I lost on that I spent on that BMW, which essentially amounts to, let's just say, $30,000 to $40,000. If I'd taken that, put it in a down payment for a house, I would have a house now. I mean, I have a house, but I would have like an investment home right now that I would be renting. $30,000 down payment on an investment home buys you about $160,000 home, which is about 1,700 square feet. Family of 2 or 3, 4 can live in it. 3 bedroom, 2 bath. You know how that home back then, 5 years ago, would have cost me maybe $160,000, maybe $160,000. That house now would sell for about $210,000.
Does this keep you up at night?
Pisses me off. and it's not like Bitcoin. Bitcoin's a totally different thing. If I had, you know, that one's one of those, well, if I had just known, like if I dropped 40 grand in Bitcoin, I wouldn't be standing here today. I'd be off on some island drinking a mimosa with my wife. So, but the real estate thing, that's realistic. I could have easily made that decision. And I made a really dumb decision on a car, some rims, and that didn't include, that car purchase didn't include the stupid rims and tires I bought. So add another 5 grand to that for the rims and an extra set of tires. So now I'm in on that car $55,000, and Honda wants to give me 11. So I hope you guys learned my lesson. Don't spend money when you're younger on dumb stuff like that. Thankfully, I'm going to drive that car until the wheels fall off, literally. And then after that, I'm going to go get a Civic. So, with that said, let's talk about depreciation. Depreciation is how a vehicle loses value, and this happens to a lot of things. A lot of things depreciate. Like everybody tells you, like diamonds are worth a lot. They're not. They're not valuable. They're not rare. They're none of those things. I bought my wife a ring. And she goes, oh, it's worth this. I'm like, no, you're not gonna sell it. It's not ever happened because, of course, hopefully we'll stay together. But the other thing is that, you know, that stuff, it's all like, it's not worth that.
Is given the value by the opposite of consumer, because I forgot the word.
Say that again.
What is the opposite of consumer?
Let me think of it. I know where you're going.
The value is only given by the person selling it.
Yes, yes. Say that again.
It's more sentimental value.
Yeah.
It's like what person.
Intrinsic value, that's not really, that's like the true value of the product or what you place on it. I'm gonna think about that. Hopefully you beat me to it.
Okay.
Okay, keep thinking, keep Googling, and we'll get it. All right, so depreciation. So let's say a car is purchased for $29,000, okay? So we're gonna start it up here. So the car's purchased at $29,000. All right, so you buy the car at 29, after 7 years, oh, it's worth 29. No, wait, after 7 years it's 2,400, okay? So I'm gonna put this down here. So I'm gonna draw a little bit of a graph here for you so you can see this. So year 0, right? Year 0 when you buy it, it's 29,000. You with me so far? Okay. Now you don't have to draw this graph. You don't have to do that. I'm just doing it so that you can kind of see the progression. 7 years later, it's worth 2,400. Okay. So it's clearly lost value. Assuming that the car's value depreciated steadily from year to year. So in other words, what they're saying is that every year it goes down at the same amount, which is not true. If you know a little bit about vehicles, is that the first 2 to 3 years is where the vehicle loses the most money. So it drops significantly in the first 2 to 3 years, and then it starts to come down steadily, and then it will level off typically at some amount depending on the vehicle. Mine is going to keep going. And other cars, like for example, like the minivan I bought back in November, that minivan is going to drop a little bit, but like for example, I think we paid like $34,000 for that minivan. I'm gonna be able to turn around, if I ever want to sell that minivan off in 5, 6, 7 years, I might even be able to sell it in like the high teens, low 20s. That's how low the depreciation is, because it's got a lot of utility and a lot of people can use it, and some people can't get into that $30,000 bracket, but they can spend in the high teens for something that's nice and well taken care of. So, but in general, your vehicle is going to drop the most in the first 2 to 3 years. Let me give you an example. I happen to like Ferraris. I don't know if I'll ever get one day, not based on my BMW, but I happen to look at the Ferrari forums and look at the classifieds, and this guy was selling his less than a year old Ferrari that he paid $370,000 for. He put 600 miles on it, and he was selling it for $310,000, and nobody's biting. So in 1 year, $60,000 off, only drove it 600 miles, and so that's unbelievable, unbelievable. So those like vehicles like that, it was a lot of money, a lot of money. And that car next year will be worth even less and less. So when about 6 years from now, that car is going to be for sale for about $190 with probably about 7,800 miles on it. That's crazy. It's unbelievable. So every vehicle has a different depreciation curve. But in this problem, they're not calling it a curve because it's going to make the problem easier to do if it's linear. If it's a curve, we have to get into quadratics, which is not this class. So there you go. Assuming that the car's value depreciates steadily from year to year, what was it worth at the end of the 3rd year? So let's go take a look here. So 1, 2, 3, 4, 5, 6, 7. Okay? So what they're saying here is that they want to know, right, if the value of this car is depreciating steadily at year 3. What's this amount? Are you guys following? Okay, so in order to figure that out, there's a few steps we have to go through. Step number 1, first determine how much did the vehicle depreciate. To figure out how much the vehicle depreciated, we take, of course, our purchase price of the vehicle and subtract the price at what it's worth at year 7. Or for you, it could be year 4, 5, 6, 9, whatever it happens to be. But you're going to take your two values, the purchase price and the current value of the vehicle. Okay? So you're going to need to get that number. For me, I think that's going to end up being what? 26.6, I think. Yeah, 26.6. Now that's not the answer, but it's an important number. So step number 1 is you need to subtract your two values, your $2 amounts. Okay? Then from there, what does that mean? That means that this gap between 29 and 24 is 26.6 for me. Then in order to figure out, since it's depreciating steadily, the same amount year on year, to figure out how much it's depreciating every single year, what do? Divide it by the number of years. You got it. Great job. So we're going to divide this number, by the number of years. For me, that's 7. For you, it could be different. Don't just assume that it's 7. Your problem's going to be different probably in this number and this number. Geez, what is that? 3, somebody put it down. 3,800. Now that's not the answer, but it's an important number. Okay? What does this mean? That means that every single year, since they state that this car is depreciating steadily, it is losing, dropping 3,800 every year. Are you guys following me? Okay? Now from here, we want to figure out what it's worth in the 3rd year. Well, if we know that we started at this and it's dropping 3,800 a year, what do we have to do? A couple ways to do it, right? You can take 26.6 and do minus 3,800, minus 3,800, minus 3,800 for 3 years, and that's going to give you your amount, right? That's one way to do it. I mean, it's okay. Or you can do what? Multiply this by and subtract it from there. Does that make sense? Either way, it probably actually ends up being the same amount of keystrokes. But just in general, it's just a little bit more intelligent to know that. Do it that way. So 3,800 times 3. Say that again.
11,400.
Thank you very much. So that's 11,400. Now, that's not the answer. But you know what's great is why is that valuable? Because if somebody asks, how much did your car lose in value in 3 years? You'd be able to tell them that. Whereas if you started at 26.6 and just dropped 38, 38, 38, you wouldn't be able to give them that amount, right? It's important to kind of know how much did I lose in value over that 3 years. So anyways, take 26.6, subtract the 11.4, and that should give you your answer at 15.2?
Yeah.
Thank you. And that should be boxed. So in other words, at year 3, we find that the value of the car is $15,200. Okay? I hope that makes sense for you guys. And I spent a lot of time, every semester I spend a lot of time on depreciation because it is a very, very important concept. Every year I talk about my dumb BMW, and every year it loses a little less, right? Because now I'm in year 6, almost 7 of that car, and it is starting to come down. Why? Because at 11,000, there's not much more it can go, right? So if I started at 50, and now I'm at 11, there's not much more that car can go. So for me, my car it's doing this. It's starting to level off. And so I happen to take good care of my car, so if somebody came around and said, hey, Andrew, I'll give you $9 grand for that car, they're gonna get a really good car that looks good for $9 grand. So if you are gonna purchase a car like that, if you are gonna have a nice car, a nicer car, or whatever luxury vehicle, always buy it used. Check the paperwork on it, and I mean, they're nice. They look good. They're a little bit different. And if you want something like that, I highly recommend you buy it used. And really, that applies to really anything in terms of vehicles. You never want to buy a vehicle new, and you want to avoid buying a vehicle within the first 3 years. If you can get something at year 3, out of year 3, that's well taken care of, you are going to do great financially, which is what most of you should be thinking of at your age. Okay, so there it is. There's number 11. Hopefully you guys are rolling way ahead of me at this point. Let's see here. Let's take a look at number 12. So again, 11 was the one that I always spend a lot of time on. The rest of these we're going to kind of just breeze through. I'll skip a few and then we'll be done. All right, so the members of the Student Activity Council on your campus are meeting as like 2 speakers for a month-long event celebrating artists and entertainers. The first names of the choices are Ben, who I'm going to abbreviate as B, Will, Stuart, Hillary, Kate, and Jay. So one way that can help you go through these problems, this particular problem, a little bit faster, is to just abbreviate their names. Let's take a look. How many different ways can the 2 speakers be selected? So when we get to chapter 11, there will be a formula for doing this. I'm not going to get into that formula. There's no point to it right now. All we're going to do is, let me just show you, which you guys are probably aware of. So in order to do this, here's how I would do it. And to never repeat anything. BW, there's 1. BS. BH. BK. BJ. WS. WH. Notice how by doing it this way, I never repeat anybody. See what I'm doing here, right? I've done all the W's. Why do I not back up and do WB? Because I already did it, right? Move on to the S's. SH, SK, SJ. And if you do it right, you should have 1 less every time. Can you see it? 1 less every time. Move on to the H. HK, HJ, and then finally KJ. By doing it this way, it's very methodical. You will hopefully never miss one. And then when you're all done, you can count them up. There's 5, 4, 3, 2, 1, 9, 12, 14, 15 total ways to pair 2 speakers up. Make sense? Okay? And that's not really like, I mean, like, you might use that sometime in life, but not really. The things that, again, the 2 things that you're really going to use, depreciation and the understanding of that concept, and then number 2 is revenue, cost, profit. Whether you run your own business or you just have a good understanding, a basic understanding of it, it's important. So let's take a look at number 13. It says traveling at an average rate of between 40 and 70 miles per hour for 3 to 4 hours. Select the best estimate for the distance traveled. I'm not going to do that one right now. I want to see if you guys can just get that one right on your own. So go do that one, see if you can get it on your own. I'm going to walk on the other half of the class and take a look at your work. All right. Nice job. Very good. Okay, good. All right, very nice. Okay, so what I would do in a problem like this maybe is I would kind of take the number in between. Maybe that's what, 55, something like that, in between 40 and 70. And then somewhere here, 3 to 4, maybe 3.5, and multiply those two together. So, I don't know, what is that, 150 something, 160, 170, maybe it's like 170. So that's not there. I'm gonna say it's probably closer to 205. I mean, I just did 55 times 3.5, like sort of in my head, but maybe 205. Does that make sense, guys? Because it says between 40 and 70 miles an hour. Well, between 40 and 70 is 55, right? 15 under is 40, 15 over is 70, around there. And then between 3 to 4 hours is in between 3.5 hours. Multiply those two together, that's going to give you some number, and go find on your scale which one seems to be closest to that. Okay? All right? So there it is. And then number 14 is going to be the last problem I do for the day. 15, 16, I'm going to leave for you guys to do. Okay? You're 13?
Did it a different one.
Say that again.
The 13, I did it a different way, and it seemed to make it a little easier for me.
How do you do it?
I took and multiplied like the 50 times the 3 and the 60 times the 6.
Found the number between in general.
And then found a number
Yeah.
later.
That's what I did.
Yeah, that's a
I
fantastic
did
one.
the small number by the least amount of
Oh yeah, totally. I think
And then divided it.
and found the range.
Yeah.
Yes. So I think that's a great way to do it. So what if you weren't following and you want to do it this way, which is fantastic. And of course, there's many ways to do many of the problems that we're doing. Like I give you one or two maybe, and then if you have a better way to do it and it resonates with you, stick with that. It's fine. So what they did, 40 times 3 is 120. That's your bottom range, right? That's the bottom half of what you could have traveled. Then 70 times 4 is 280. Of course, this is my problem, right? So that's the upper limit. Lower limit, upper limit, we have to be somewhere in between. Well, this is pushing on the upper limit, so that's probably not it. This is a little bit closer to the upper limit. This is under the lower, so this is for sure out. This is for sure out. Which one seems to be more in the middle? The 205. So that works too, okay? So whichever way works best for you, work it, okay? All right, wonderful. Glad you threw that out there. Let's look at 14, shall we? So in 14, what you have to do is determine a route whose distance is less than 12 miles for running errands to all 3 destinations and getting back home. So let's make sure we understand this. The criteria, there are a couple criteria. Less than 12 miles. Does that say less than or equal to 12 miles?
No,
It does not. So when you do this problem, like yours might be 11 miles or 10 miles or 10 and a half, whatever happens to be. But when it says less than and it doesn't say less than or equal to, that means you can't come up with a 12 and be right. It has to be 11 or less, 11 and a half, 11, anything besides 12 or greater. It has to be less than 12, okay? The second criteria that you have to meet, besides the distance being less than what they state, is you have to hit all of the destinations. So you have to start at home, you have to go to the bank, post office in no particular order, the dry cleaners, and then you have to get back home. So that's your criteria, whichever way that ends up being. So you have to hit home, your errands, and get back home in under 12 miles. Okay? So let's take a look at mine. If you're looking at yours, that's great. So I'm just going to put I'm going to write this as an H here because that's where home is, but it doesn't show up completely. So let's take a look here. So if I do home to the post office, there's 3. I'm thinking that if I go post office and dry cleaners, there's 4. If I go dry cleaners to back home, there's another 4. Does that make it? It does. Now, if I had gone to bank, dry cleaners, and home, 4.5, 8.5, I would have made 11.5. That was another week. Wait, did I mess that up? 3, 7, 11? No, I got it. No, I missed the bank. So I can't do that, right? I've got to go with my garage. That doesn't work because I missed the bank. Here, here, and here. So home to post office to the bank to the dry cleaners back home, 5, 7.5, 11.5. There it is. Okay, so I mean the bottom line is that just go find the route that works, and it's just a matter of looking at it and doing a little bit of math. Does that make sense? Okay. Homework and quiz are due by our next class before it starts.